Find the slant asymptote, if applicable, of r of x equals 2x cubed minus 4x squared minus 2x plus 5 over x squared plus 4x plus 1. In order to determine if we have a slant asymptote, we have to compare the degrees of the numerator and denominator. The degree of the numerator here is 3, and the degree of the denominator is 2. And for a slant asymptote to exist, the degree of the numerator must be exactly 1 more than the degree of the denominator. In this case, it is. Okay? And so, that tells us there will be a slant asymptote. And in order to find it, we do a long division of our rational function. So we have our 2x cubed minus 4x squared minus 2x plus 5 over x squared plus 4x plus 1. Okay, so now we've got, what do we multiply x squared by to get a 2x cubed? That's 2x. And then we take this 2x and we multiply it by this whole thing. So 2x times x squared is 2x cubed. And then 2x times 4x is 8x squared. And 2x times 1 is 2x. And then we subtract that. Okay, so here we the 2x cubed cancels. Okay, and then we have here negative 4x squared minus 8x squared, and that is negative 12x squared. And then we have negative 2x minus 2x, which is minus 4x. And then we have our plus 5, and there's nothing to subtract from that, so we just have our plus 5. And then we do it again. We say, what do I multiply x squared by to get negative 12x squared? And that is negative 12. And I take that negative 12 and I multiply by all of this. So negative 12 times x squared is negative 12x squared. Negative 12 times a 4x is a negative 48x. And negative 12 times a positive 1 is negative 12. And we need to subtract that. And again, this first term will cancel, so those are gone. And then we have a negative 4x minus a negative, so plus 48x. And that is 44x. And then we have 5 minus a negative, so plus 12, and that's plus 17. Okay, now at this point, what we have down here has a smaller degree than here, our dividend, so we know that we are finished. And the quotient is the equation of the slant asymptote. So y equals 2x minus 12. This is our slant or oblique asymptote.